All right, guys, continuing our discussion from yesterday, we were talking about relations. Today we're going to be talking about functions. We're going to learn how we can identify functions as well as find the domain and range of relations and functions. If you take a look at your note guide, it's pretty wide open. You have a lot to write down. In the box, I want you to save some room for these first four definitions on the right of it so that we can put an example there. I'm going to start off. A relation is just any set of ordered pairs. You guys know what an ordered pair is? Give me an example of one. It's going to be any x, y value. Set then would be denoted with these curly brackets, so you might want to put those down. That means you have a set and you would put the pairs inside. The next definition is domain. Domain is going to be the set, so again, curly brackets, of all x values. It's what goes into your function. It's your input. If x is your domain, y is your range. So the set of all y values is your output. It's what's coming out of the function when you put x in. It is your output. You might want to think of a way that you can remember that y is paired to range and x is paired to domain. We can share these tomorrow in class. One example that I give you, one way that I remember it as I think of range has the G hanging over, y hangs over. Domain is written straight on the line, x is written straight on the line. That's how I taught myself to memorize things. Hey, if you got something else, that's awesome. Whatever works for you. A function then is a special relation that pairs each domain value. It pairs each domain value with exactly one, and I want you to capitalize that. It's very important. So it's exactly one range value or y value. All right, so make sure you have those four definitions before you move on. You don't have to write this down, but here's an example, okay? Anything can be a relation. It's just a set of ordered pairs. So for instance, maybe you take some data from a track meet. First place you get 5 points, second place you get 3 points, third place you get 2 points, fourth place you get 1 point. You throw those into ordered pairs and you put them in curly brackets and you now have a set. So I want you to copy that example down next to relation on your paper. 1, 5, 2, 3, 3, 2, and 4, 1. So I'm going to put it right here. 1, 5, 2, 3, 3, 2, and 4, 1. This is an example of a relation. Okay, it's a set of ordered pairs. If I asked you then to find your domain, you need to list all of your input values, all your x values. You want to make sure you list them in increasing order. And you also want no repetition, okay? So if the same number is listed twice in your x value, you only list it one time in the domain. I'm going to list my domain with a D, put a little colon, and then you make a set, okay? It's all the x values. What are my x values from these ordered pairs? 1, 2, 3, and 4. They're already in order for me, so that's perfect. There's your domain. I now want to list my y values, my range. Same thing, guys. List in increasing order, no repetition. I have 5, 3, 2, and 1. So I want to put them in the order of 1, 2, 3, and 5. Close that set off. There's your domain and your range. Is this a function then? I'm asking you, does each x go to only one y? So if I put 1 into a machine, a function is kind of like a machine. You put something in, you get something out. If I put the number 1 into this machine, I get out number 5. Okay? It's a function if you always only get out that answer. Later on, if I put in 1 and got out 3, it would not be a function. If I put in 1, I get 5. If I put in 2, I get 3. 3, I get 2. And 4, I get 1. That is a function. So yes, it is a function. And we're going to talk more about this tomorrow and later in these notes. All right, so there's one example for you. That needs to be in the box on the top of your page. On the bottom then, you want to express a relation in 3 different ways. So I'm giving you this relation. I want you to make a table, a graph, and a mapping. Notice my headings here. Table and graph, you guys should be good to go. A table is just an XY table, so go ahead and fill them in. 2, 3, 4, 7, 6, 8. We should go with that. Graph, you should be pretty good with that too. Try to use some straight lines and space everything out evenly. All right, so I'm going to go, maybe remember you move x then y, over 2, up 3, over 4, up to 7, and over to 6, up to 8. The last thing then, the only new one really here, would be the mapping, okay? So what is a mapping? You may have seen these in your textbook. You're going to have the x values paired to the y values. All the x values are going to be listed in this little bubble, and all the y values are going to be listed in this bubble, okay? You put them in order. So you put them in order from least to greatest again. 2, 4, let me get rid of some of these lines here. 2, 4, and 6 are my x values. They go right in here in order. 2, 4, 6. Same as your domain, okay? No repetition, in order from least to greatest. Then your range, same thing. No repetition, in order from least to greatest. They go over here. 3, 7, and 8. Then all you do is you draw an arrow of which x goes to which y. So because my point is 2, 3, I'm going to say 2 pairs to 3, 4 pairs to 7, and 6 pairs to 8. Will all of your lines always be parallel like this? Not always, okay, just for this example. You see the next one has a couple different ones. Before we move on to the next part, because I know you guys need a little bit of humor in your life, here's a little quick joke for you. It says, old mathematicians never die. They just lose some of their functions. So just a little riddle dealing with functions, because that's what we're talking about for today. Hopefully you liked it. All right, last part here, guys. Number 2. Find the domain and range of the following relations, and then you're going to tell me whether it's a function. You may want to write this down at the bottom. Remember, a function means that each x is paired to exactly one y. Okay, each x is paired to exactly one y. Take a look here at A. Let's list our domain and range first. Remember your domain, x values, least to greatest. 2, 3, and 4. I'm going to put them in that order. My range, y values, least to greatest, no repetition, -5, -4, -3. Is each x paired to one y here? Here's an x. It's paired to one number. That passes. Here's an x. It's paired to one number. That passes. Take a look at number 2, though. 2 is paired to -5 and to -4. Is that a function? Is each x paired to exactly one y? Hopefully you're saying, no way. No, this is not a function. Okay, now let me give you a counter example here. What if I had the same numbers, but I had 2 arrows going to the same value? For instance, maybe I had 4 and 3, but they were both going to -5. Would that be okay? Is that allowed? Is each x paired to one y? Yes. Okay, that is allowed. Y can come from as many x values as it wants, but the x's cannot go to more than one y. All right, let me know if you struggle with that tomorrow. We'll work on a little bit more. Second one, I could give you a set and ask you to do the same thing. Remember, domain is your x values. Hopefully you've already started this. Range is your y values. All you're doing is listing them out. Here's my domain. I want to put them in order from least to greatest. So I got -6, then -4, then 1, then 8. My range, 2, 1, 2, and 9. I want to list them in order from least to greatest, no repetition. So 1, then 2, then 9. All right, is this a function? Take a look. Does any x go to more than one y value? If the x values are all different, 8, -4, -6, and 1, what does that tell you? If the x values are all different, what does that tell you? It is a function. 8 is going to one value, -4 is going to one value, -6 is going to one value, and 1 is going to one value. So yes, this is a function. Last one, guys. This one's a little bit tricky. Okay, we have a graph. I'm talking about the parallelogram that I'm giving you, and I want to know what's the domain and range of this parallelogram. Think first just about the x values. Think first just about the x values. Take a look on the x-axis. This is what I want you to focus on right here. Where does the graph span on the x-axis? Hopefully you're seeing that x could be -5. Right here, x is -5. Over here, x is -4. Also, x is -4 right there. X is -3. X is -2. X is -1. Hopefully you're seeing what I'm doing here. So I'm taking a look at where this crosses the x-axis. Is there an ordered pair for that x value? You might need an inequality for this. So let's think about the bounds. Here, x is less than what number? What's the highest number that this graph reaches over on the x-axis to? It's less than or equal to, what's the x value right here? 1, 2, 3. It's less than or equal to 3. It also, we have to think about what's the lowest value that x reaches. So what's the leftmost point on this graph? What's the x value at that point? 1, 2, 3, 4, 5. X is greater than or equal to -5. You can put curly brackets around this, but typically in the textbooks, we won't put curly brackets around this inequalities, okay? So here we have to give a range. Now let's think about the range. We want to think about the y values. Where does it span? The y-axis. So instead of left to right, you're looking up and down. What's the lowest point? What's the highest point? Is there a point everywhere in between? You can see here, there's a point as far down as -2. Is there a point on there that has a y value of -1.5? If I go down to -1.5, look across. Is there any point? Right here and right here. So you notice on this time I'm working my way up. So I'm going to say y is greater than or equal to -2 because that's the lowest point on this graph. Every time I move up, there's still a point at that value until I reach the highest point, which would be all the points along here. What is y? Anywhere on that line segment, it is 1. So it's going to be less than or equal to 1. Again, with inequalities, we don't typically put the set brackets on there. Last thing you have to do before we identify if this is a function, I'm going to have you write down this definition down here. The vertical line test is used to determine if a graph is a function. If any vertical line passes through the graph at more than one point, it is not a function. Okay, so get that down. What I mean is you can draw in a vertical line anywhere on your graph, okay? If it touches more than once, it is not a function. Let's draw a line in right here. Right now, if I draw a line, does it touch more than once? No, it only touches once. So right now, I might think it's a function. Guys, when you do this test, you need to make sure you do it all the way across the graph. So keep going. Draw in some more vertical lines on here. As soon as it crosses more than once, you know that this whole thing is not a function. Do any of those lines cross more than once? Absolutely. Hopefully you're saying yes, yes. Look right here. It's crossing there and there. Therefore, is this a function? No. Think about the points that are occurring there. At that value, we might have x being -2, 1, and x being -2, -2. So is each x paired to one y? No, it is not. So this one is not a function. You're going to practice this more. Okay, just keep it in mind. All right, last part then I want you to do on your own as part of the extremely exciting ticket is answer the right about question. That's it, guys.